once again, you're welcome to my channel. This is Brain Booster. I am here to give you tips on work and jam questions. I will teach you based on their syllabus, and as you listen, just pay attention. If there's any question, you can ask me in the comment section, and I will be there to reply or answer you. Thank you. Today we'll look at electrolysis. Electrolysis is one important topic on our chemistry, in CD and physics. It's a topic that both physics and chemistry share. Let us start. What is electrolysis? It's a method employed in purifying metals. Normally we extract metals from their ore. Metals are gotten from their ore form. Metals are extracted from their ore form. And since metals are gotten from their ore form, they are supposed to be purified. Normally we now use electrolysis as a way, a method employed in the laboratory or in an industry to purify these metals, to get these metals to get them in their pure state. Remember, metals are seen combined in their combined with other impurities. It means that metals are seen with their ions. Are we good? Now look at metals are called what? Metals are called cations. Then non-metals are anions. Anions, negative charge, cations, plus charge. Therefore, I can say Ca is 2 plus, I can tell you O is 2 minus. I will call Ca, which is calcium, a cation. I will call O, which is oxygen, an anion. Sorry, what is even an ion? An ion is an element that has either lost or gained electron. An ion is an element that has either lost or gained electron. Ion, I-O-N, ion. So it can either be a cation or it can either be an anion. But the two of them, they've lost electrons. Back to what I am saying, they've lost electrons. Now, look at it. There are factors that decide or determine the preferential discharge of ions on the electrode. Now, what are electrodes? Electrodes are poles through which current enters or leaves the electrolyte. Electrodes are poles. This class is just based on electrolysis. So I'm just bringing up terms and things that concerns electrolysis. Electrodes are poles through which current enters or leaves the electrolysis. Now we have two poles. We have two poles, electrodes. We have plus and we have minus. The plus is called cathode. The minus is called, the plus is called cathode. The minus is called what? Anode. Please, just like the other way around. Cations have lost electrons. Whenever a metal gives off electron, it becomes plus. Whenever an element receive, any element that will receive is called a non-metal. Every non-metal receive electron. Then the metal gives out. So they give to become plus. Non-metal receive to become minus. So whenever you want to purify them, e.g., I extracted them zinc, and zinc that I extracted was found with its impurities. And in that impurities, I need to do what? I need to do what they call electrolysis. To now do how I can, to look for how I can separate my zinc or my iron from its impurities. Now, after doing that, I will do that with the what? I will use my what? I will use this method in doing that. Now, the cathode, I have cathode. The cations go to the cathode to receive electrons. To receive what? To receive electrons. The cathode and the anode. The cathode is seen with a negative sign, the anode with a positive sign. The cation negative, and the anion negative, the cation positive. Let me break it down for us once more again. Look at Ca. Let me use Mg. Magnesium is 2 plus. Let me use a non-metal, fluorine. is minus 1. This Mg2 plus is called a cation. This F is called an anion. This one has lost electron. That's why it's plus, it's a metal. This one has gained electron. That's why it's carrying minus. So anytime you see an element with minus sign, it means it has gained. Anytime you see the one with the plus sign, it means it has lost. When they are being found here, if I put a compound containing Mg2 plus and F minus 1 inside to electrolyze, it means that this Mg2 plus will now go to the cathode. The cathode has enough electrons. It will now give this magnesium equal number of lost electrons to become a normal magnesium. E.g., look at it, cathodic equation of Mg magnesium. Mg2 plus will receive 2 electrons to become a normal magnesium. A normal what? Magnesium. Look at how it is. So if Mg was 3 plus, e.g. aluminium, if I'm not asked to write aluminium, therefore aluminium Al3 plus to receive 3 electrons to become what? Aluminium metal. That's how it goes. So sodium Na plus will receive just 1 electron to become a sodium metal. Now from Faraday told us that 1 electron is equal to what? 96500 coulombs. It's a constant for Faraday first law. 1 farad is equal to 96500 coulombs. We can equate farad and coulombs. But please, while solving, look at your option. I know your answer is in farad or in what? In coulombs. I will take my time to see how I can break this thing down. Now, what are the factors that determines the preferential discharge of electrons at the electrode during electrolysis? See, if in this base now I have magnesium, I have aluminium 3 plus, and I have boron. Boron is 3 plus. What factor, which one will come out first? If you have been asked. During the electrolysis, I have 3 metals. Which one will come out first? Now, number 1 factor. Factors that affect the preferential discharge of electrons at the electrode. Number 1 will have concentration. 1 will have concentration. 2 will have catalyst. 3 will have position of the electrons on the electrochemical series. 1 we have catalyst. 2 we have concentration. 3 we have position of the electrons of the metals on the electrochemical series. Now look at this thing now, very important. Let's look at this position of the electrons on the series. Now let me give you the decreasing order from the highest to the lowest. We have potassium, sodium, calcium. This is the decreasing order. It is the decreasing order of on the electrochemical series. This is the decreasing order. It means that this from potassium, sodium, calcium, magnesium, Al, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. Gold is the least. It means that whenever I'm trying to bring out my pure element, look up. Zinc cannot come out before aluminium. Tin cannot come out before zinc. Zinc will come out before iron, before tin, before lead. So therefore also, number 2, element lower than the other cannot displace another in a reaction. If I'm having a reaction, if I'm not being constrained, or if there's no condition in that particular reaction telling me what is going on the normal reaction, there's no way copper will displace hydrogen from steam, because copper is below hydrogen in the electrochemical series. There's no how calcium will displace sodium, because sodium is higher than calcium in the electrochemical series. So this chart will help you to know which element will come out before the other. Let's look at this now. From Faraday, he told us that Q is equal to IT, current times time. Q, quantity of charge in coulombs, is equal to current times time. Current in ampere, time in seconds. Let's pick one example as I round up. Look at this example now. What example? Just one. Now, a current of 2 ampere was passed. A current of 2 ampere was passed in a solution of aluminium salt for 100 seconds. 100 seconds. A current of 2A was passed in a solution of aluminium salt for 100 seconds. Find the mass of aluminium deposited. In bracket, AL is equal to 27 grams, comma. Then we now have 1 farad is we now have 96,500 C. The first thing I will do is to look at this. Write my equation first of all. Aluminium is 3 plus 3E is equal to aluminium. If I do this now, it will now be, if I do this, please pause it.